This first video is the start of section 3.2, units of measurement. And as you know, in the United States, we use what is sometimes called the English units or the imperial system, and those are miles and pounds and inches. Those units that are really only unique to the United States. The rest of the world uses mostly what we call the metric system. And the metric system is great, but in science, we have sort of an expanded view of measurement. It's something that's called the international system, and most of them are the metric units that you're used to. These were created so that, and that's as you see in the middle box here on our notes, and that was created so that scientists have what we could call a common language. From where one scientist can describe to another scientist their results, and each one can understand the other. Right? And this became really important as scientists started to be able to communicate to each other. And something like temperature. That was very difficult because every city used to have its own system of describing temperature. And then finally, it was decided on that we're going to call the boiling point of water, which is 100 degrees Celsius. We're going to call that 100. The freezing point of water we're going to call 0, and that there will be 100 individual degrees in between. And therefore, no matter where you are in the world, you can make a Celsius thermometer. So what are the international, what are these base units? So we call them base units, SI, or System International. You know, in some languages, we change the placement of the adjective. So the SI base units, so these are the ones that we just decided everything is going to be based around, and we use metric prefixes to modify them. They are based on standard values in nature. And that is so everyone can determine like what is a kilogram or what is a meter without having to, find someone else's to base it off of. So there are some of these you're not really going to need to know for class, and some of them are going to be very important. The first one is very important. What do we measure with a kilogram? Look at the picture there. That's right, it's mass, right? That would be like a pound. In the English units that we use, we are going to be using kilograms or grams. We'll talk more about those in a moment. The next one, what is measured by a meter? Of course, that's length. What is measured in seconds? That's of course time. And this one is something new, and we're going to use this so much this year. It is something called the mole, and it measures the amount of a substance that you have. So if I were to say that I had a kilogram of lead versus a kilogram of helium, those two would contain a vastly different number of atoms. And if we want to compare those, we want to actually compare how many there are. That's what we use the mole for. An amp or an ampere is what we use to measure electrical current. A candela is a luminosity or luminous intensity. And a Kelvin is what we use to measure, of course, temperature. We're going to talk a lot more about these in just a moment. But the bottom of this page talks about something a little different, talks about what are derived units. So derived units are units that we use that are, of course, derived from other units. Some of those they're similar to calculations. So for example, so derived units are formed by multiplying or dividing. These are made from the base units. So, do you know, let's start over here, with what is length over time or a distance over time? And you know, sometimes we call it speed, but in science we often call it velocity. Now, what is length times another length, symbolized by this square right here? That's, of course, area. And when we have a length times a length times a length, we would be measuring volume. We'll go into more detail on both of these. When we take mass and then multiply it by the acceleration, usually the acceleration due to the gravity, or due to the gravity that we experience here on Earth, this might be force or weight. And a change in speed over time is, of course, how fast you are accelerating. So this is acceleration. So the unit that we're going to talk about right now is the unit called the mole. And I cannot stress enough how much this is going to be what most of chemistry is really going to be all about. After about midway through the year, we talk about a mole every day. AP Chemistry, a mole every single day. So as I said before, it's what is used to count how many particles there are of a substance. And when I mean particles, it could be atoms. If I'm talking about something that exists as atoms, such as lead or neon, any sort of element. It could be an ion, like a calcium ion or an oxygen ion, or a molecule, which could be glucose or even an oxygen molecule, like the ones that we breathe. It could be anything, but this number is really, 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 really big. It is 6.022 times 10 to the positive 23rd. It's called Avogadro's number, and it's giant. There's a way that we figured it out. We'll talk about that when we talk about the periodic table, actually. Why did we pick this ridiculous number? There was a reason for it. It wasn't just out of the blue. It is 60 sextillion. If you think about like a billion, bi means 2, we got to go all the way up to 60 sextillion. It is a giant number. We're talking about like the grains of sand on Miami Beach. There has never, if you count every human being that has ever existed, you get nowhere near this number. So it's really quite giant. Okay, and so we call that a mole. Now, so this number is a giant number, but look at this picture here. This picture shows us what a mole of each one of these substances looks like. So some of them, you can see the bigger molecule here, sucrose. Sucrose, that's another name for table sugar. This is literally just sugar that you have in your cabinet at your house. A mole of sucrose molecules has about this volume. Whereas a mole of salt, sodium chloride, has a much smaller volume. That can tell you something about, well, a sucrose molecule must be bigger than a sodium chloride. You wouldn't call it a molecule, we'd call it a formula unit, and it does, right? Copper 2 sulfate pentahydrate, super cool kind of blue looking substance as opposed to copper. You can see copper is just a singular atom, and so a mole of copper atoms is much smaller. And again, what are we talking about with this idea of particles? Whatever is the smallest unit of that substance. So we would say a mole of copper atoms is 6.02 times 10 to the 23rd atoms. As opposed to, if I say a mole of water molecules is 6.022 times 10 to the 23rd molecules. A mole of calcium ions is 6.022 times 10 to the 23rd calcium ions. So it just depends on what you're talking about. You could have a mole of people, you could have a mole of cats, a mole of munchkins, but those, when you talk about a mole of something that you could actually see, it's a giant, giant number. Okay, so oftentimes, so that's a mole. We're going to talk about a mole much more in a few days and throughout the rest of the year. Let's go back to this idea of what those metric prefixes are. And I know that you've done some work with this in other classes previous to chemistry. So you've talked about a centimeter or a millimeter and maybe even a milliliter. So we're going to need to know those metric prefixes. I'm going to tell you which ones specifically you need to know. In general, you need to know that there are some metric prefixes that make the base unit larger. So for example, mega and kilo, they make our base unit larger than it normally is. So a gram is about the size of a paper clip or about the mass of a paper clip, where like a kilogram is about the mass of a kitten. So you can see like it's much bigger. Conversely, the other way around, many metric prefixes make that base unit smaller. And so centi and milli are probably ones that you know. And of course, they do make that smaller. You know, a meter is about a yard, but a centimeter is maybe this big, and a millimeter really small. Okay? You are also going to need to know micro and nano for this class, because we're going to be talking about things that are very small. So we're going to need to know those too. So units of length, just to give you some sort of idea, a proportion, right? What is a meter? It says the height of a doorknob from the door is about a meter. You know that we always talk about a meter is about the same as a yard. So you can have some idea about that. I always thinking about a football field or a soccer field as being about 100 meters long. That gives you an idea as to what that is. You will often also use the word kilometer, right? It says the length of a kilometer is about 5 city blocks. That's difficult for us to understand, because a kilometer being about 5 city blocks, what's a city block? If you think about the distance, if you stood on the road outside our school and walked all the way around to get to that same point, that's about a kilometer. The other ones, we know centi, milli, micro, nano. You can see that they all get much, much, much smaller. Units of volume. Now remember, volume was a derived unit. And there's one piece of this that is super duper important. You're going to need to really get this into your memory, is that a cubic centimeter. So think of this as about a centimeter. And think about a cubic centimeter there. So a centimeter times the centimeter times the centimeter. So that centimeter cubed is equal to the volume of 1 milliliter. Those two things are identical. They are completely interchangeable. And then that's what we actually base a liter off of. So a liter is the base unit. It's about a quarter milk. If you think about, a lot of soda now comes in 1 liter containers. You have an idea about that. You sort of know what a cubic centimeter is, and that's same thing as a milliliter. Microliter, very small. Use microliters a lot in biology, actually. And then mass. So kilogram and gram. And I'm going to take some time here to really try and get you to understand the difference between the two, because oftentimes students will make an error in this case. So a kilogram. Remember, kilogram begins with a K. That is the mass of about a kitten. Okay, which also begins with a K. So think about small cat, obviously. You know what a kitten is. A gram. A gram is about the mass of a large paperclip. And this is one thing that is really important. 1 kilogram is equal to 10 to the third, or 1,000 grams. Remember that 1 kitten has the same mass of about 1,000 paperclips. And I really want you to think about that, because at some point this year, you're going to write on a piece of paper that 1 gram is equal to 1,000 kilograms. And I am going to, mark that. No, that's wrong. That's not right. Because I'm going to say, do you really think that 1,000 kittens weighs the same thing as a paperclip? And you're going to go, oh, she told me I was going to mess that up. So please just be very wary about that. It is something that students often mess up. So I'm pointing it out. So hopefully you won't. And then finally, units of energy. All you need to know is that in chemistry, we use the unit of energy that's called a joule. In the English system, there's many, many different units of energy. One that you may be familiar with is a calorie, and you may have learned in a previous science class, or even maybe a food science class, that there's such thing as a food calorie, and a food calorie with a capital C. is equal to a kilocalorie. Those two things are identical to each other. And